Hey guys, Laird here, and today I'm coming to you with a new tutorial. So first of all, let's create a new project. I will just make a simple blueprint third-person project. You don't need to create a project, you can just follow along. I'll take starter content, I'll create a project, and in the meantime I will tell you more about what this tutorial is about. Sometimes when you need the element of the interface, user interface, UMG is not something that you would want to use. And the reason for that is UMG doesn't handle HDR, for example. So you cannot have glowing stuff. You cannot have progress bars with some material effects and so on. And in this tutorial we'll try to fix this. So I'm just gonna play, see what's up here. So I have a character. He can jump, that's nice. Now we will make a health bar without UMG at all. So we will use something else. Let me just open the character first. It's almost a different screen. And for a health bar, we need health, right? So we go here. Let's make a health variable. Now, some people use float for health, and then they use another float for max health. I do a little bit differently. It's not superior approach. It's just, for me, it's a little bit more convenient. So I use vector2d. Now, what is vector2d? Essentially, vector2d is just two floats in one go, essentially one variable. So we say 100 out of 100. Okay, nice. So now we have this guy. And let's just test this a little bit. I'm gonna go and use, let's see, tick. So every frame, we're gonna just go ahead and print our health, okay? Okay, sorry. Get health, split the structure pin, because this way you can get access to x and y variables, which is x is this variable, y is this one. So I think it's pretty convenient. You can just have health and max health in one variable. So let me see. One thing we can do is we can divide so we can see how much percentage, so to speak, of health we get. So we compile, save. We can just click play right here, and we see it gets 1. So the difference between health and max health is 1, because we divide essentially the same value by the same value. Now, what we want to have is we want to have a health bar somewhere on the screen so that it follows the camera, and for example it glows. Okay, that's just a simple way to do it. First of all, I'll show you how to make something that follows the camera. So here we're in our content folder. We're gonna make a new folder just for convenience. Call it materials. Let's see. And here we're gonna create new material. Let's see, progress bar. Now, what you usually would do is you would create a widget and then just assign like a color to it and assign it to the health variable and add the widget to the viewport. But again, if you want to have, for example, a glowing health bar, this will not work. So let's first just make a glowing bar, okay, that glows just by itself. So we just put here like 10. So again, 0 is black, 1 is white, 10 is glowing white, you know, emitting a lot of light. And before we connect it to anything, we're gonna have shading model or shading mode unlit, because we don't make we don't want this surface to receive any light. We just want it to emit light. So emissive, we get just pure white, and you see it glows. We save this material. Material is really easy, so it's really not heavy for GPU to process. Now we go to our character. Here is our guy. Now I want you to take a look at this structure. You see this camera boom, which is essentially a so-called, I don't remember, is it called lever or something like this? So this is the cool component that has this, yeah, it's like an arm, right? You can make the long arm, and then what you can do is you can rotate the arm itself, and you don't have to rotate the camera. Oops, let's see. I think this guy is just bound. Yeah, right, because the arm is connected to our, it's connected to our mouse rotation. So we cannot rotate here. Well, of course, you can change this easily. So the cool thing about ARM is that, I'll make just a quick demonstration here. If you get through the wall, the arm probes the collision. And if you collide, it goes closer. That's nice. So how do we make a health bar or just a bar here? Well, we can make it a child of camera boom, because camera boom rotates with the camera, right? With your mouse rotation. So if you attach something to camera boom, it's going to rotate with the camera as well. And we just use static mesh. I'll just show the easiest method that I use, and we say progress bar mesh. Now we don't want this progress bar to interfere with anything, so we just say, okay, no collision, okay, and no, don't generate overlap events. I think it's, if you say no collision, you don't need to say this one, but you know, just in case. Attach it to camera boom. Now it's child of camera boom. And static mesh, the easiest thing is that shape plane. Shape plane. Why? Well, because shape plane has really like what, 4 polygons or even 2 polygons, or let's see how does Unreal calculate it. Oh, it actually has like 32 polygons for some reason. I don't know. Anyway, where were we? We were here. Okay, nice. So with this guy is attached to camera boom. Now let's move the guy forward. Just quickly check. Nice. The guy is just following the camera now. And of course, if you go here, it's also with the camera boom. So how do we turn this in the bar? First of all, we rotate it so it faces directly the camera, and we can just again just play. If you click play, it compiles automatically. Okay. Now it's in front of us. Nice. All we need to do now is make it look like a bar. So I clicked R, or I pressed R to scale. Now we get scaling tool. We put this guy here. Compile, save. This is our bar. You can see what's cool about this is that he always follows us. But if it clips through the character, you can see that you do not see part of it. This problem is solvable if we get back to our progress bar. By the way, don't name your materials without the the material word there. I will fix my mistake right now. I would click rename or press F2, say progress bar material, so that it doesn't get confusing. Because otherwise you click here, you say progress bar. Is it a widget or is it blueprint? Well, actually it's material. So here, let me see, somewhere here there was, let's see, two-sided, just gonna, it's normal, translucency, separate, responsive, disable, okay. So opaque will not work here. Okay, let's make it material a little bit more expensive. So translucent material. Not a big deal for us. If we keep everything like it was, opacity will still be 1. Now we can say disable depth tests. And I will show you in a second what it does. Okay. So now, well, actually it still clips through. I don't remember why would it do this. Yeah, let's see. Ah, right, because sorry, we don't use this one. So now, well, it wouldn't work without disabling depth test. So now, okay, sorry, sometimes I move a little bit too quickly. What I did is I clicked on my material. Now it's selected. I get back here. I press this button. So now it uses, this mesh uses this material. I say, okay, compile, play. Now, you can see what happens. It clipped through anything, it will never be abstracted. Why? Well, because translucent materials are rendered, in a separate source, so to speak, pass, essentially. You look at Unreal docs for more information about this. And if you disable depth test, what it does, it says, okay, I don't check if it clips through anything. If it's abstracted on the screen by anything, I will just always render it, okay? And that's what we need, right? We want this bar to be there. Of course, it's not the best case scenario every time. But let's just adjust this guy a little bit so it's more down there. Let's see again. Now it's too low. A little bit higher. Maybe this. Okay. Now it looks somewhat like a health bar on the bottom. Maybe you don't need it on the bottom. Maybe you want it to have to be on the right side of the character. There are many options. We will just keep it here for simplicity. Okay, so we have this guy. Well, how do we actually change its change the progress bar fill, essentially, depending on our health level? Well, first of all, let's make sure that we can damage our character. We go back to the code. Let's see, we had this guy, event tick. Let's do it differently. Let's print health, not every tick, but, you know, every once in a while. How to do this? Well, let's see. We will start in the begin play. Begin play is like a stuff which is called after the construction of the object for every actor on the scene. So when you start playing and this actor appears, this will be called. So you go here, then you say set timer by event. And event, you carry out this red thing here, you say custom. And we say print health. So what happens? Well, this is a delayed thing. You can only make these timers in event graph. So this thing will say, well, after a certain period of time, call this function. So we call it, in languages like JavaScript, we call it asynchronously, all right? Because begin play will not wait for this to happen, okay? If you, for example, if you print here something else, it will say, I will set the timer, for example, on every half a second. And before waiting half a second, I will continue execution here. But, you know, at the point where the engine says, okay, half a second passed, then it will call this thing. Why is it useful? Well, we put here like 1 second. We say looping, which means that it will call this every 1 second, okay? And here we will print our health. So once again, we go here, we get split structure pin. We take X, which is the current amount of health. We're not interested in max health for now. We say print. Click this thing here. We say that we print it in green. Nice. We save just in case. Play. And then you see every second on the left top, it prints our health level. And you may see that there are only 2 lines, sometimes 3. And why is that? Well, because every line lasts 2 seconds. So before the 3rd line appears, the first line in the stack disappears, okay? So now we see our health, nice. Well, what do we do next? Now we need something to damage us, okay? And also we need a mechanic which will apply the damage to our health. Well, this is really easy. We already have a damage system implemented in the Unreal, so we say event any damage, okay? This event will be called when any kind of damage is applied to the actor. There are point damage, there are area damages, many types of damage. Also, there is a damage type thing, which is a different story, okay? So this is really easy here. When we receive damage, we will set our health variable to something else. Now, what will be something else? Well, let's also split the input here. First of all, max health will remain the same, right? But the current health, which is health X, right, the first one, will be changed. Well, how it will be changed? Well, you subtract from current health the damage. But you might get to the negative health, okay? So here we will take this one and say, okay, take a maximum of either the resulting health X or 0. What does it mean? Well, when the resulting current health, which is X, is like 10 or 5, anything more than 0, this thing will be outputting this resulting health. When you get to the point where, for example, you have 5 health and the damage is 10 health, you get -5. Well, maximum we'll see, well, -5 and 0. 0 is bigger than -5, so we take maximum of these two, which is 0, and output 0. Why is it required? Well, you don't want sometimes to have negative values in your health. Now, after this setting, what you would usually do is you would say, well, now I'm checking if I have 0 health or below sometimes, just in case. And if I have 0 below, I die, right? You put here your death mechanics. I don't have death mechanics, and I'm not going to implement it here. So we're just going to stick to this really simple formula, okay? Now we can receive damage. Well, how do I apply damage? Many ways again. We can put some enemies, but let's do something really simple because we're just testing. Okay, here we have different volumes, and there is a pane causing volume. Okay, let's put this guy here, and let's make it slightly bigger. Okay, now I'm just gonna, and if you wonder why my interface is so weird, I use ultra-wide monitor right here, but this one is a smaller monitor, and I shoot tutorials on smaller monitor because you know, if you watch ultra-wide not on ultra-wide, then it's kind of pain. It doesn't look that good. All right, so here, let me see. Can we actually show the guy? Collision actor. No, I was just wondering if we can show the box in the game. But okay, let's say not. Damage per second. Let's put there like, yeah, one damage per second. Let's put 5 maybe. And let's say that we damage every 2 seconds. Okay. Entry pain, yeah, okay. When you enter, and yeah, when you enter the guy, you'll also receive pain. Nice. So this is here. Save. Now we need to test it out. So we remember where it is. We say play. Somewhere here. And then you see that you slowly receive damage. So you see that it's 70, 60. 50 and so on. Okay, so we're receiving damage. Now we need our health bar to actually work. So we have all set up. Now we can just dive into the real topic of this thing. Progress bar material. Okay, first of all, a little bit of theory. There's a thing called texture coordinate. Okay, and I'm gonna really quickly explain how it works because we really don't have that much time. Don't get confused by the looks of it. What texture coordinate is essentially a two-dimensional array of vector 2's, and it works in a way that when the GPU is rendering the surface, let's say this is the surface, right? And what it does is that it runs your shader code, this is a pixel shader code essentially. It runs your shader code for each pixel on the screen which displays this surface. So, for example, if we just look at camera like this, it will run for this pixel, this pixel, this pixel, and so on and so forth. Now it has to have some kind of way to determine if we put there here a texture, for example. Let's see, texture parameter, or maybe texture object works. Yes. Let's say we have like this guy, this weird guy. And if you see, if I put here, oops, no, texture 2D is not compatible with whatever. It's texture object. Okay. I'll put here texture parameter 2D because this guy should work. Okay, and I just select a weird texture like this guy. Okay, it compiles. It's pretty slow as always. Yes. Okay. How does this? How does the GPU, when it runs the guy for every pixel, when it runs the code, how does it determine that, for this spot we can put from this texture, the pixel which is red. For this spot, there's a green pixel and so on. Well, it uses the same method as we were going to use now, which is texture coordinate. So imagine that it runs for every pixel. Imagine that it runs for this pixel. And it says, well, okay, what kind of texture coordinate is here as an input? And the answer is 0, 0. When it runs on this pixel, it says, well, what's the texture coordinate input here? And it says 0, 1. Here it's 1, 1. Here it's 1, 0. So essentially, this is really easy to demonstrate. If I mask out one particular, because this is, remember, this is vector 2, okay? So it has red and green here, but it's just in case, okay? It's not because it outputs colors. It actually outputs just coordinates for the GPU or for you when you write your shader. If I mask out a red channel, you can see how it looks. Just put here. If we just take texture coordinate and just put red channel, which is X channel, into the output, the GPU runs on every pixel and it says, well, what is the result here? And it says 0. Well, the result here says 1. Here it will be 1, 1, but we only take X, so it's 1. Here it will be 0, 1, but we only take x, and x is 0, okay? So think of it as basically an input that you can work on, which will let you understand for this particular run of this shader, which is essentially a micro program, where are you on the surface, okay? And if you take red channel, it says where are you horizontally? The lesser the output of X channel or R, the closer you are to the left. When 0 is the leftmost pixel on the surface. 1 means the rightmost pixel, okay? How do we use it? Okay, this is really easy. So imagine that we have a progress bar, and this, you know, the more it's filled, the more it's health. So if it's fully filled, it means that we have full health. If it's not filled at all, it means we have 0 health. And health goes from left to right. Well, first of all, let's introduce a scalar, scalar parameter, which will determine the fullness of our health. So let's say it's 0.5. Yes, and the parameter name, I don't know how to name it better. Healthfulness. Okay. So how do we use the healthfulness? This will be the parameter that your pawn inputs into this material. Okay. Then we take our texture coordinate. We mask R because remember we need only horizontal. And then we say, well, okay. If this thing, for example, here, and we compare it to this thing, 0.5, if this thing is bigger than 0.5, let's put here 1 because I don't remember which order will be there, was there. Bigger or equals, we output 1, and you will see the result in a minute. If it's less, 0. 1 is white, 0 is black, remember this. This will be the output. Okay, I messed it up. It's the opposite. Boom, boom. Now it's fine. Okay, so what did happen? Well, now, because we know that for each coordinate in the texture, for each run of this micro program, this shader on the GPU, it will have a different texture coordinate depending on where we are horizontally. We can compare our current horizontal position to this healthfulness. And we say, well, if we are still, let's say, on the coordinate which is halfway, and our healthfulness is 0.5, we should fill this halfway coordinate in the middle, right, with white. But if we're currently running this program somewhere around here, you know, closer to 1, then we output black because our health is 0.5. So for first half we output 1. For other half we output 0. But of course we want more than that. But let's first make sure that this one works, right? So this is really easy. We save this material. Now, for now, if we just run, we have another problem here, because we messed up horizontal and vertical. And so what we need to do now is we need to actually we either swap it here or we swap it here. Let's swap it here. Let's swap it here. Instead of using horizontal, we use vertical. Okay. Here it will look weird because we're filling it like this now. But here it works just fine, okay? Now you can see this kind of weird blurring happening. This is the result of the fact that we're using translucency, okay? So if you don't want this, you can just go here, forget about translucency. Instead of translucency, use masked. Why masked? Why not opaque? I will explain a little bit later. Of course, we cannot have disabled depth tests because of this. But there are some ways to work this stuff out, okay? For now, we will have this issue, but let's just concentrate on material. So there's that. How do we output our current health there? Well, again, pretty easy. In the begin play, we want to make a dynamic material instance of our material. Why? Because dynamic material instance offers us the opportunity to change the parameters of the material in runtime. We have a parameter here. We have scalar parameter healthfulness. Scalar means basically float here. So we go here. Then we go, in the begin play, we go create material, create dynamic material instance for, and you can select here, progress bar mesh. What this does is it creates dynamic material instance and automatically assigns it to progress bar mesh, okay? Progress bar mesh, dynamic material instance. What is the source material? Well, it's progress bar material. We take source, progress bar material, and we promote this guy to a variable after it creates. So this variable will be stored in this dynamic material instance so we can reference it. And then we say progress bar material instance, right? Nice. Sorry if the sound is a little bit clunky there. My microphone is really close and I cannot take it further because it will not catch anything. Okay, hopefully it's bearable. Okay, so we have this guy. Now, you can update the amount of health every tick. I do not recommend it usually. Usually we have only certain things that can affect our health, and if we agree that the only way how our health will change is through event any damage, then we can just, after you take any damage, this is the only situation where the health changes. So it makes sense to only then update our material. Okay, how do we update it? We get it first. Then we say, let's set scalar parameter value. Okay, here. What is the parameter name? Go here. Healthfulness. You can just copy paste. Control C, Control V. Healthfulness. What is the value? Well, as you imagine, it takes value from 0 to 1, because if you go 0.2, you can see that white becomes small. If you take 1, it becomes white. 0.5. Remember, this is we rotated this in our character, so character looks a little bit different. We split our set. Now, this output is essentially this, after you set the value, what will it equal to? So this is just convenient for us not to take, our health again and say get and, put it here and split. Instead, we just get it out here. So we just divide our current health by our max health. And as you remember, this will give us exactly what we want. It gives us value from 1 to 0, depending on how much health we have. 1 is full, 0 is empty. Exactly what we need. We get it here. Nice. And let's also do this one time during begin play, okay? Because we need to set our health at the begin play, which is, we need to make sure that it's maximum. It looks like maximum, and it looks like maximum now. We go here, we take some damage, and you see what happens. Health decreases. Nice. Okay. So one thing I would do as well, we have masked. Masked means that we can alter the opacity of it. But masked also means that we can also only have it either fully opaque or fully translucent, or transparent, sorry. And again, it's really easy. Let's just take this guy, and we already know what it outputs. It outputs white for the health that we have and black for the health that we don't have. But opacity mask takes exactly this. So just look at this. If you don't understand it one time, try to, pause the video and watch it, think about it. Maybe watch this part again. I take this out and I put this to opacity mask. Now you see it's black. Okay, why it's black? Well, because we need to put something to emissive color. We put there 1, which means white. You can see the result is exactly what it was. Why? Because now it gives the opacity mask white values for all health we have, which is half, black values for all health we don't have, which is other half. Now, the cool thing is that opacity mask says, okay, if the input is white, I render color. If input is black, I don't render anything, and it's transparent. Okay, so if we save now, watch what happens. The bar is white. Nice. We go here, the bar decreases. Cool. Of course, the downside of this is that you don't see how much do you have. I will show you how to fix this. We'll go here. Let's just organize ourselves a little bit, and we will make a typical case where green means full health and red means empty health, right? No health. And we will make 3 vector parameters. How we make 3 vector parameters really easy. You hold 3, you click, hold 3 and click. Okay. These are constant. So full health is green. We put green to 1, everything else to 0. Sorry, it's red, but you get the point. So empty health. Full health is green 1, everything else is 0. Nice. Now we say, well, what is the color? Well, let's linearly interpolate. So lerp. We lerp between red and green, and the alpha is the current value that you want, right? So lerp says, well, how much of A and how much of B will depend on the alpha, which is from 0 to 1. Our healthfulness is also from 0 to 1. We put here, boom. Now it's yellow. Let's check it. If we get lower, it gets more green. Okay, that's exactly the opposite of what we want, so we just swap them. BA. Now you see it gets more and more red, the lesser health we get. Okay, and if we go here, it gets more and more green. Sometimes you want to have more reds, you know, earlier, right? Here, for example, we want already to show when it's at 30% health, we only want to show some red, not this orange or yellow, whatever. So how do we solve this? Many ways. Let's just make a formula a little bit more complex. Let's take a power of this healthfulness and let's put power of 3. Now the power will not affect value 1. When full health, 1 in the third power is 1. But the lower health we get, the steeper the curve, which, you know, makes the value even lower. Put here alpha. Okay, you can see that it gets red already at 30%. Here it's even more red. On 70% it's already yellow. So you can experiment with this. You can put here like 2.4 maybe. Okay, and then again you put here like 27%. That's already great. Okay, kind of what we need. Nice. So now you can pause here and look at the shader again. We don't need this guy. Save the material. And go here. And now let's receive some damage. Boom. Boom. You can see it becomes more and more reddish. And it goes there. Nice. So, let's at the end, let me just show you how I would, you know, use this kind of opportunity, because let's be honest, you could do this kind of stuff with UMG, right? You could make this kind of thing and it will not clip like this. It will not blur when you make it translucent. So, you know, you would ask, well, what is the point of this? I will show you. How would I use this one is I will take these colors. I will introduce another scalar parameter here, which means that I can alter it somewhere. I will call it glow. Put default value of maybe 15. And when we get this value, our lerp colors, remember, from these colors will be from 0 to 1 somewhere. If we multiply them by a lot, like 15, they will start glowing. We get this guy glowing maybe too much, so let's put here like 10. Nice. This is the kind of stuff you still cannot do with UMG. Let's try playing. Nice, it glows like a crazy thing. So to prevent this kind of lens flare, I'll just go here, post-processing volume on your normal map. We have lens flares here. Let's just turn them off, or okay, maybe make them a little bit there. And threshold is bigger. And maybe bokeh size bigger as well. This will make them more like blurred, and you know, you nearly don't see them. So now we have our glowing health bar, and you see it decreases. Nice. So this kind of thing is, you know, what I would also do is I would go scene color. I would add a lot of fringe to make the glowing thing even, you know, more apparent there. This kind of stuff, you know, you can make any kind of complex shaders and put there, you know, they can be glowing and doing crazy stuff, and they will all work. And again, if you want this thing to just not clip through anything, you put it translucent, you put here disable depth test, And this will not remove the blurring, I believe, but let's just check. If we just remove all motion blur, okay, and click play, yeah, actually doesn't blur that much. So again, now it clips through any. Now it's totally fine in terms of clipping. Actually, we damaged something here, I think. Yeah, because we made it. Yeah, it's my fault. We made it translucent. Translucent uses opacity. Opacity means that not only 0 and 1 are acceptable, but something in between. But we don't use this anyway. We need a translucency only for the fact that it doesn't clip through anything. So now you see it decreases normally, and it also doesn't clip through anything, which is pretty useful. Now, of course, now you can just do whatever you want with it. You can maybe put the guy, let me see, stretch him like this one and like this. Let's just not overdo it. Put him here. Let's see. No, that's too crazy. See here. More understandable. Maybe even put him near the character, so you get this, atmospheric kind of user interface, so to speak. Maybe make him even like this. Okay. And now we just, because the bar is now vertical and we didn't rotate it, we go here and we change the channel here again. So we go from G to R, sorry. So it will now be horizontal. And we click play and it works, and we go here and you see what happens. Now the bar decreases like this. And again, it doesn't clip through anything. So it's always in front of you. So there are some limitations. One of the limitations is that you don't get the UI scaling that you would get through UMG. But, some cool stuff, and most importantly, the glowing stuff, because I love glowing stuff, as you can see from my tutorials, you can make great from this one. Thank you for watching this tutorial. If you have any questions, and again, sorry for the audio quality, working on it. If you have any questions, I will be happy to answer them in the comments section. And, see you guys later. And bye-bye.